Food waste is a significant global problem because almost 1/3 of the food produced worldwide is wasted or lost each year, which generates an estimated 1.3 billion tons of wasted food. Therefore, properly processing wasted food has become an important global environmental issue. In addition, yard and garden waste, grass, leaves, and brush trimmings, accounts for another major portion of municipal organic waste. Like food waste, it too needs to be properly processed. Currently, most of the food and yard waste goes directly to landfills and incinerators. However, the rotting foods in landfills produce methane, a greenhouse gas that has a warming potential 20 times greater than does carbon dioxide. This will make global warming even worse. Food and yard wastes can also be transformed into fertilizer by composting or by anaerobic digestion, which produces biogas that can be used for households and businesses as an alternative to natural gas. The major disadvantage of both methods is that these treatment processes require a large amount of land to accommodate the processing facilities, because both composting and anaerobic digestion are relatively slow processes. Because the output is a single product, access to a large market is usually required. Hence, this limits the feasibility of these two solutions. An innovative technology called Purify, which stands for the process of utilization of renewable ingredients from food and yard waste, was recently developed by a team of researchers at the Institute of Nuclear Energy Research. It not only provides a solution for properly dealing with the problem of food and yard waste, but also allows multi-utilization of organic waste. Although the composition of food waste is very complicated and more likely to contain a relatively high amount of water and oil in Asia, food waste and yard waste contain different types of sugar. The Purify technology includes a non-toxic and safe chemical and enzymatic method. It can first separate and extract, in liquid form, the sugar from wastes. The liquid sugar can then be used as a nutritional supplement for animal feed or as a substitute for molasses in many instances. Purify has also developed a microorganism that can metabolize and convert various sugars into ethanol. By using this fermentation technique, liquid sugar obtained from waste can be further converted into bioethanol, which can be used as transportation fuel or as chemical building blocks in many industrial applications. Moreover, the leftover solid residue from the bioethanol conversion process can also be used as solid fuel for a heat and electricity cogeneration system. Or it can be used in composting or biogas production, simply because of its reduced water content and lack of easily perishable sugar. Although this residue is unseparated and unidentified, it is still a useful organic byproduct. Thus, Purify technology is not only a standalone application for the biorefinery industry, but it is also an integrated application that is useful for existing food waste processing facilities for environmentally safe landfill, compost, and biogas production.
After being depolymerized, the structures of lignocellulosic materials are destroyed, so the hydrolysis efficiency can be increased dramatically. If the depolymerized lignocellulosic materials are used in biogas production, productivity can be significantly improved. To stay in line with government policies and international trends, the Institute of Nuclear Energy Research, INER, plans to integrate biogas production with biomass thermoelectricity in the future to make a contribution to the world's energy development. In addition to being used in biogas production, lignin, which accounts for 30% to 40% weight of the lignocellulosic material, can also be purified by the whole composition separation technology of the Institute of Nuclear Energy Research, INER. In addition, lignin can be used to make carbon fiber, graphite felt, and other value-added products. Carbon fiber has the advantages of lightweight, high strength, etc., which can reduce weight and save fuel when used in vehicles. Graphite felt can be used as a sort of additive material. Its brilliant thermal insulation property makes it an ideal fireproof material capable of insulating intense heat, while its porosity and great conductivity makes it an excellent electrode material for storage of renewable energy. In the future, INER will continue to refine the technology of depolymerization and saccharification and develop related value-added products such as polylactic acid, FDCA, and long carbon chain biocompounds. Polylactide can be used in a wide range of fields, including all kinds of packaging materials, utensils, medical materials, and building materials. Based on the principle of environmental friendliness, our technology for producing polylactic acid is devoted to replacing the plastic products on the market. Biopolylactide is decomposable. Therefore, products made from it do not harm the environment as much as plastic products do after being discarded. 2,5-furan-dicarboxylic acid, FDCA, is a material for producing the polyethylene 2,5-furan-dicarboxylate, PEF. Compared with traditional plastic materials, PEF has better air blocking capabilities and mechanical properties. It can also extend the expiration date of packaged products while reducing the use of packaging materials. These advantages have made FDCA exceptionally valuable. The method mainly used lignocellulosic materials for FDCA production, and the manufacturing process not only complies with the principles of green chemistry, but also avoids controversies caused by chemical product manufacturing and sacrificing food production for energy production. This technology has been granted a patent by the Republic of China and won the third prize at the 2017 Taipei International Invention Show and Technomart. Currently, we are actively seeking advanced cooperation partners in our preliminary FDCA production plans, and negotiation with one manufacturer is underway. Long carbon chain biocompounds. To combat global warming, the International Air Transport Association has laid out plans to curb carbon emissions. By marrying aviation biofuel with technologies for enhancing engine efficiency, it is estimated that the goal of reducing carbon emissions worldwide by 50% can be achieved by 2050. However, if no measure is taken, the carbon emission of the air transport industries are expected to increase by more than 150% of the baseline value, posing a threat to the environment. Compared with other technologies that entail energy-intensive manufacturing processes accompanied by fierce chemical reactions, the technologies adopted by INER are based on moderate fermentation. Aviation biofuel can be easily extracted from the fermentation medium, thereby ensuring a relatively stable manufacturing process. INER planning strategy is based on utilization of strains for fatty acid production. Through genetic engineering, large amounts of free fatty acids that meet the requirements of the aviation fuel specification for carbon number can be produced, and products of fatty acid created during the process can also be transformed into polymers, which increase the potential for diverse applications.
In summary, the unique features of the purified technology create innovative value from food waste recycling. Its full utilization of the organic wastes demonstrates its practical application for for environmental protection, agricultural development, and renewable energy.